All right, everybody, let's do some wave velocity equation calculations. So here is wave velocity calculations. Link to the assignment. All right, so whenever they ask for speed or velocity, we're going to use this equation. Let's see. Let's look for it. Just want to make sure I write it correctly. So the background, frequency, wave motion, wave speed. Here we go. Yeah, velocity equals wavelength times frequency. So V stands for velocity, which we've seen since the beginning of this class. This is lambda, it's a Greek letter. Looks like an upside down Y. The wavelength. So that, again, that's from crest to crest or trough to trough. And then frequency is how many times it's moving per second, right? So how many cycles per second. So let's look at some of these problems. All right, so for number 2, let's do number 2. A wave with a wavelength of 0.4 is determined to have a frequency of 1,000 hertz. 0.4 meters. Wavelength, what is the wave's velocity? Oh, we don't know what velocity, sorry. Wavelength is 0.4 meters, all right? So formula we're gonna use, I think I like using the drawing function. So the formula we're gonna use is velocity equals lambda times frequency. Now we're gonna substitute V equals lambda, which is 0.4 times 1,000. And the units, let's see, meters per second. So 0.4 times 1,000 is 400 meters per second. Very easy. It's a 3-variable formula. It's not too hard. So that's velocity. Then you'll notice, let's look at number 4. If a sound is heard at a frequency of 650 hertz and the speed of sound is 343 meters per second, what is the wavelength? So we don't know what the wavelength is. That's number 4. So wavelength, we don't know. Frequency is 650 hertz. And the velocity of sound is 343 meters per second. So now what formula are we going to use? Well, we want to solve for lambda, for wavelength. So let's do that. Insert drawing. So we've got velocity equals lambda. Again, I messed up my lambda. So that's lambda times frequency. So we know velocity and we know frequency. We just don't know lambda. So we have to solve for lambda. So we're going to divide by frequency. Divide by frequency. So frequencies cancel. So now I have my formula lambda equals velocity divided by frequency. So you could just copy this over here. So now we substitute. So I'm going to put velocity divided by frequency. And it should be the units should be in meters, right? Because it's a distance. You can measure it with a ruler, wavelength to wavelength and all that. So that's number 4. One last one that I'll go over, I'll just give you the formula, is number 6. If you see a flash of lightning and measure the wavelength of the thunder produced at 0.67 meters, what is the frequency of the sound? The speed of sound that day was 334 meters per second. All right, so we know the speed of sound. Speed of sound is pretty constant. They're asking for frequency. We don't know what frequency is. What is lambda? 0.67 meters. So formula. So let's figure out the formula. Insert drawing. So we've got the old formula for velocity. Velocity equals lambda times frequency. So this one we want to solve for f, right? Because we know v, we know lambda. So all I have to do is divide by lambda, lambdas cancel. So frequency is equal to velocity divided by lambda. And then it's a frequency, so the units of frequency are in hertz. So answer in units. So make sure you fill each one of these squares out. You could draw them, you could type them, whatever you want. Seems to work pretty well. That's it. That's the assignment. Not too difficult.